Hi everyone, I'm Hebub and I'm here to show DataLineage Doctor, an automated root cause analysis that is RCA expert for data platform. In modern data stack, when a pipeline breaks or a data quality test fails, the manual investigation is a nightmare. You have to trace upstream dependencies, check ownership, and calculate the blast radius. DataLineage Doctor changes that. It is an intelligent agent that sits on top of open metadata. The moment an incident occurs, it wakes up, exports your lineage graph, runs a full diagnostic, and provides a full incident report to the dashboard along with in your Slack channel. So this is a kind of the high level detail of the incident detail, how the agent generates the RC report. And since the video has a time constraint, I'll be very quick to record this demo. You can definitely read and go through the demo here. So this is the architecture and this is the tech stack. I have used a custom LLM reasoning loop that uses a suite of tools to interact with the OpenMetadata REST API and a FastAPI backend for the API and dashboard with celery workers handling a long running RCA task. And for source of truth, we pull all lineages, quality, and ownership data directly from OpenMetadata. And for observability, I am using Prometheus and Grafana to track agent performance, success rate, and confidence score in real time. So, and this is how I have used OpenMetadata integration in this project. So now let's see the demo. So I have actually deployed the whole project, the whole stack in server, and I have deployed in DL Doctor, Data Lineage Doctor app. So let's go to the DL Doctor at the tab. Yeah, so this is the front end you can see, and you can definitely go through the project here, but I will be very quick. So for the info, you can see I have actually this is the docs for the project, and I have actually made public all the open metadata, Grafana, and Prometheus. So it is in the subdomain. You can see the open metadata stack, the Grafana here, this is the dashboard, and this is the Prometheus, all in separate subdomain. So this is the dashboard. You can see I have already made a few incidents. These are the incidents that I have already made. And so let's trigger an incident. So what is an incident? Incident is that we'll be placing something, we'll be making something wrong in the data plane so that the RC agent behind the scene can actually work. It is actually simulating the real world incident, real world incident happening. So let's say I'm triggering an incident. I have triggered an incident, and this is actually a short polling. Behind the scene, it is actually querying the to get the latest incident report. If you see the network tab, you will see it is actually polling to get the latest report. And once it is done, it will be automatically updated in the dashboard. So let's wait a few more seconds. It generally takes 20 to 30 seconds. Yeah, you can see the report is generated. I triggered it into 8:39. It is 8:40 right now. So this is where the incident happened. This is the time. This is status. The confidence, the agent is confidence is high. The blast radius is one. It is the blast radius is just one section. And now let's see a view how the report is generated. This is how the report is generated. It just does not only see the upstream, it also sees the all the evidence and how it has gotten the decision, the remediation step, and it also generates a graph that from where and which tables were. These are the upstreams, the root cause. These are the upstreams. This is the root cause, and this is the downstream that might be affected. So that might be affected. So the engineers can actually they do not only read the data because sometimes it is doesn't our head gets stuck by info, but the visually we actually get more productive. So this is why I'm creating a lineage graph to actually show where the thing has actually gone wrong. So this is the timeline how and the incident occurred. This is the blast radius, in which table the it might be affected more. So if we go to the dashboard, and so yeah, dashboard, and I will be triggering another incident, creating another incident now. And if I just refresh, you can see, and yeah, just refresh and you can see this is it is in the processing state. So this is the sort pooling as I already told you. So you can see this is it has a 4 blast radius. So get view it, and you see these are the 4 tables that are actually affected by this issue, by this trigger. You can definitely see it here. So this is it actually generates the full blast radius report, the timeline, and the root cause, the evidence chain, and the how we can actually make things happen and make things right. So now this is not only that you will get this in the dashboard, you will also receive a report in the Slack. So if we let's say this is the time 8:42, I have just it is 8:42. You can see this is the time I have received the RCA complaints, a high confidence and zero downstream consumers. You can see this is the latest zero, and this is also zero. This is one blast radius. So this is the time 8:49, 8:29, 8:40. There is just two incident. So you can see in 8:42, in 8:42 there was two recorded and triggered, and both zero downstream consumers. And in 8:49 you can see just 8:42, 8:40 there is one downstream consumers. So we get a detailed report in Slack also. So if you want to directly see the incident, we can directly go to the incident and we see the incident report directly from here. So this is actually I have tried to solve the problem to for the data team. Actually, the project was a huge milestone for me. I actually discovered OpenMetadata through this hackathon only, and I have explored myself in the domain of data engineering to solve real world problem like automated RCA has made me incredibly confident. So I have realized how powerful a unified metadata layer is, and I'm definitely willing to explore this stack further. And Data Lineage Doctor is just the beginning of how we can make data platforms truly self-healing. Thanks for watching. Um, Wait, one thing, I just want to stop this video by quickly showing how I have deployed this. I have actually deployed in a 16 GB server. Yeah, you can see this is the 16 server, and the full stack, the whole stack is actually consuming 4 GB of RAM. So we can see the logs here, make prod logs. You can see this is the logs actually happening. So thank you so much for watching this video. I'll be releasing a detailed video for this project very soon.